Previously on Fearlessdarkelf's journey.
And surprisingly, it was much quicker than what I anticipated it to be. Usually, Transx is a real pain in the ass, but this time it actually was fairly simple for me to use this time. There's going to have to be a mid-course correction, which means this will change, and that's what I love about this simulation program. Orbiter is really good with keeping things realistic. 3, 2, 1, burn. Okay, so here we are. We are starting the burn, and we will be going towards the moon. What I want to do is make it to where we can just slingshot around the moon and back to the Earth, but not everything is going to go as planned, because not everything is perfect.
And now his journey continues.
Hi, I'm Fearlessdarkelf. In the last video, we had ended it off with the burn to be able to go to the moon. We're going to go to the moon, circle around, and come back. So that being said, let's continue the trip. So as you can see, the moon is just right there, and it will be coming closer and closer towards the middle right here. What we'll have to do is make a mid-course correction. So let's go to the moon. Before I do anything else, let me take this off, because we don't necessarily need to see all the constellations and all that. And now what we're going to do is do an outside view and watch the Earth slowly go away. So here's Earth, here's us. And watch it get smaller as we go away. Bye bye, Earth. We'll see you in 8 days. Because it takes about 4 days to get to the moon. Okay, so that's that. Goodbye, Earth. Now we just go prograde again towards the moon. Okay, let's go prograde. Okay. And you can tell where we are by this line right here on Transx. And we're getting pretty close to our destination, so we're going to have to slow it down, go to prograde. See, the moon is getting closer. Let's turn off prograde. And we got to be very careful with this as the moon is coming up. Now it's a good idea to do a mid-course correction. But let's see where the moon is actually going to be with this. Let's speed it up, but not by much. 1,000 should be good for now. Okay, we are now at the moon. Let's go prograde. Okay, this says we are going to be, hold on, let's do reference. We're going to be 8 million miles away from the moon. Now, that's not necessarily good, but that's pretty far. Let's get off of prograde. We need to turn 90 degrees towards the moon, so we have to go to 270, which will be right here. Okay, a little off. That's not bad. So, not bad of a mid-course correction. Yeah, it's pretty good, actually. Okay, that's pretty close to it. 154 kilometers above. That's pretty good. Okay, now this is going to affect our trajectory to Earth. So it looks like my plans for just going around, because I thought I was going to be closer than the 8 million that we were to the moon, I'm going to have to slow down, make an orbit, and set a course towards Earth. And making a course to the Earth is a lot easier than it is towards the moon. You don't have to use transects. All you have to do is use Earth itself as a visual target. You aim it just a little before the atmosphere, and then you do the burn, as I will be showing you here in a moment. So we are going to get to the moon by speeding up. We're at 100k. This needs to be a little faster than that. So let's go to 10,000. Okay. A little bit more. Okay, right here is good. We can, at this point, go to retrograde to slow down. Now that we've gone to the retrograde position, I can take off transects. I can go to burn time calculator. From here I can just hit circularize, because as you can tell, it's already set to time to periapsis. So I just have to hit that and wait the appropriate time, which is 1125 seconds. We don't want to wait that long. That is a half hour worth of waiting, and I am not just sitting here for a half hour. So that's the beauty of time warp. You speed up the time and you go down to a decent amount of time to slow back down. I usually like to do it within. Never mind. I try to slow it down within 30 seconds, but I'm not always quick enough to do it. But at least I'm down to the appropriate setting now to be able to do the circularization, and we'll be able to pull that off. This is going to be 40 seconds worth of a burn, so I figure while this is going on, I can talk to you about one other thing. The burn to the earth is not going to be perfect, so that's going to have to be correctable on the way there, but it's going to be good enough to where we will definitely make it to Earth. We're going to have to do a mid-course correction on the way there, but using the Earth itself as a visual target for the burn is the easiest way to go about it. You'll just have to do a mid-course correction like I already said. Now let's go to prograde. And then we can take off completely. We can just turn off that MFD because I'm not going to need it from here. Now we go until we see Earth itself. Okay, we have the Earth. No. We have Earth in our line of sight right now, so all we have to do is turn to aim towards the Earth. Right there, as I said, just a little outside of the atmosphere. That's actually pretty good. It's better to aim a little more inward towards it, though. And you just make the burn. And this will make it to where we can go straight back. How long is this burn going to be? Well, from here, I think about all I have to do is set it up to where it's I'm really not sure how far away to do it, so it's better just to aim, and once the this orbit line goes out past the area of the screen where it can detect it like that, it should be good enough to be able to get to Earth. It should. So we stop that. Now the problem is we need the targeting area right here to go right here where our heading is, to make sure we are going to actually make it to Earth. So let's do that. Let's speed up the time warp just a little bit, not too much, because we don't want to overshoot it. And that's good right there. And now we can just go to prograde. Make sure that it stays on there. And we keep going. Look how big the Earth is getting already. Okay, now we just do reference Earth. This says we are going to be quite a ways off. So we're going to have to actually aim it much closer when we get to that point. Right now we can turn off prograde, keep going, gotta get closer to it. Once we get into its strong gravity well, which I believe is 40%, we'll be able to make the mid-course correction to actually make it into Earth orbit. We're almost there, 40%. I thought it was at 0.4, but 0.5 should actually be more accurate. Getting there, 0.6, 7, 8. There we go, right here. Now we just need to, okay, I slowed it down just a little much. Go to prograde. Where's prograde? No, we don't. Okay, go to prograde. Okay. Turn towards Earth. And we do, no, let's just go to the full proper 270. Oops, that was 280. And I overshot that. Just a little more to the right. Right there. Okay, that's good. Now we burn. And we keep going until the periapsis goes down to 200 kilometers, which is a low Earth orbit, which is exactly where we started off at when we took off and circularized our orbit. And that would be a complete trip to the Earth from the Earth to the Moon. I am not going to do a deorbit and try to land on Earth for many reasons, one of which is I haven't practiced it enough, and quite frankly, I really suck at it. So it's just going to be me going into a standard low Earth orbit, and that would be the end of the video. Here, let's. Oops. Okay. Yes, it's a little slow going, but that works. I need to bring this down. Back up here. And right there. Oops. Keep going. Oh, okay. I thought that number started going down. Okay. And the reason why this is always moving, I have to correct it, is because we're messing with our orbit. We're messing with our trajectory and where our path of flight is going to be. So this is going to have to be corrected several times. Okay, 13. 10 million, that's pretty good. Okay, I'm just going to keep the angle right where it is. We're dropping it down. Okay, 279 is good. 220 is even better. A little bit more. Right there. 200.1 kilometers above the Earth. Now we go prograde. And there we go. This looks like it's further out than that, but is going to change the closer we get to Earth. And Earth is about to get a lot bigger pretty quickly because we're going to time warp. Okay, right here. We need to go prograde. We're at 149. It wouldn't hurt to go a little quicker. There we go. Let's speed it up. We can lessen this just a little bit if we wanted to, but I'm going to say we're pretty good. So let's just use oops. Here, let's go prograde. That was my mess up. I thought I was on translation. I did not switch it. Okay, so let's go to translation thrusters. And let's use those to slow down. Okay, apparently I'm speeding up. So let's kill the prograde. Let's slow it down through translation thrusters down to a decent amount. I could use the retro engines, but that's it'd be quicker than this way. You know what? This is actually pretty good. 260 will be actually a good height. No need to try to get it exactly where I want it. I mean, it's good where it is, so I might as well just leave it there. Okay, let's go back to prograde. Okay, time for periapsis is 3,000.7 kilometers. Or no, 1,000, sorry, not kilometers. 3,600 seconds. So that's several hours ahead. I think that's about 3 or 4 hours. That's going to be a little bit. So let's time warp this. To where we just need to slow down. Okay, right here is good. We need to go to retrograde. Okay, that's good. And now we just need to set up burn time calculator to again circularize. And we are almost done. Alright. And this time I will slow down the time warp at the appropriate time. Right here. See, slowing it down a little bit more. 30 seconds is pretty good. Let's speed up just a little bit more. 17 seconds. Okay. I was a little worried I was not going to be able to get this as well as I did. I thought I might have to slow it down and do a burn for making a proper orbit at a few million kilometers above the Earth. So I'm doing much better than what I anticipated to do. I'm actually glad I got my best deorbit to Earth done on video. That's something I'm actually quite proud of. So this is going to take about 4 minutes of a burn. I do not want to be sitting here doing that, so let's just speed that up. There we go. Let's go to a prograde position. And here we are at Earth. I hope you've enjoyed these videos. If you want to watch more, leave a comment. Tell me where you want me to go in the solar system. Unfortunately, Orbiter does not have every moon and every celestial object in our solar system. It doesn't have the asteroid belt, which is actually good because getting around that would probably be a pain in the ass. It doesn't have Pluto. Even though it's a dwarf planet, it's still something that's in our solar system we should be able to go to. But Orbiter allows you to be able to go to all the planets and all the more well-known moons for those planets. So if you want me to go to any of those, just let me know. I'll take the trip. So that's it for the video. Like, comment, and subscribe. This is Fearlessdarkelf signing out, and thank you for watching my video.